In this video, we will learn how we use GIS here at HRSD. In this video, I'll be using ArcGIS Pro, which we discussed in a previous module. See if you can remember the uses and benefits of using this program. Sometimes we deal with large data sets. These have thousands of individual features and can sometimes be overwhelming to both the user and to our computers. Some of the largest data sets that we work with frequently is the customer premise data sets from CCMB. These datasets contain all of our current customers that we serve. Each customer is represented in GIS as a point, and we have two different point layers for our customers. The data we create and maintain is used in many different ways, so we need to tailor that data to fit the needs of the different departments that use our data. Of the two layers, one has a point on each customer's rooftop. This is for spatial analysis and mapping. Later in the video, we will use this data set in a demonstration. The other data layer maps each customer in what is called a navigable point, which puts the location at the roadside rather than on the top of the roof. This is used for the mobile workforce software that the account investigators use to generate driving routes for tagging customer doors, shutoffs, and turn-on work orders, plus any other uses that require generating driving or navigation routes. We update these layers quarterly, or if there is an issue identified with a specific customer's spatial data. Sometimes out in the field, the account investigators will send us corrected information or a request for updated location data to find a specific customer. Just like at the beginning of our class when discussing what a GIS is, these account investigators are an active part of HRSD's GIS, as they are active users that not only use the data, but send updates and corrections to GIS data. Let's look at the customer premise layers in ArcGIS Pro to get a better understanding of what we have been talking about. Here you can see the difference between the 2 point layers. We will turn on the navigable and the customer premise layer, and we'll zoom in to see what they look like. The rooftops, which are blue and have a little R, represent the locations on the rooftops, and the navigable points are the pink and have a little N inside the circle. And you can see as we hover over a street that the rooftop points are falling on the rooftops and navigable ones follow along the streets. We can also turn on the CIS investigator zones so that we can see all the coverage for the account investigators. These zones cover many customers, and with routing information, the work order software that the AIs use can make efficient work routes and schedules for each zone. We can also look through the attribute tables to see the information we store for each customer. Here we can see an identifier field and then information for each customer. We have addresses, we have coordinates in different formats, account numbers, we've got service areas, investigation zones, and other information that is relevant for the departments that use this data. So now we'll go through a spatial analysis exercise using this data. We're going to calculate water consumption for a specific catchment, and we need to find the daily flow to support a possible new connection to our system. So let's navigate to the area of interest and then check out the data we are working with. So here we have moved to the Kiln Creek area. In some of our data, we have a selection of customers here in these points, and a water consumption table of information. The water consumption table, you can see, is a standalone table, as we discussed in a previous module, where it does not have any spatial data tied to it. It is just a table with a list of information. To perform this spatial analysis, we will need to combine the information contained in this water consumption table to the point layer of customers in the Kiln Creek area. And you can see the point layer for customers just has an identifier. So we need to join these two together. And you will see here the customers in Kiln Creek. The points have a identifier here that matches with the water consumption table. So we will use this field to join because they have matching fields. And going back to what we know about joins, they have to have a common field and a one-to-one match. So let's perform that join. So now, looking at the customer layer that previously only had this Prem ID field, we now have all the information from the water consumption table added on to the end of it. So now we have a completed data set, and we need to select the customers in a specific catchment. The catchment we want to find is labeled York 38, and this ties to the York County 38 pump station. With the catchment layer turned on, we can see there are many different locations or many different catchments in the area. So we should label these catchments to find the specific one that we're looking for, which is York 38. So now that the catchments are labeled, we can look and see where our points are and look at the different labels to find York 38. It's right here. So now that we have identified York 38, let's select it and highlight it in blue. Now that we have identified our catchment, we can now select by location the customers that fall within this polygon. So we've now selected all of the customer locations that fall within this polygon. And now we'll open up the attribute table for the customers to see which ones have been identified. So the selected customer locations are highlighted in blue, and we can isolate just the ones selected. So it looks like it selected 328 customers. And now we'll look at the fields available to find the one that we're looking for, which is daily gallon. And here, since they're isolated, we can visualize some statistics, which include mean, standard deviation, the number of rows, but also over here, the sum. So the sum of the daily gallon for this area, for this specific catchment, and all of the customers that fall within this catchment are 153,081 gallons per day. So with this calculation, modelers or engineers can determine necessary flow for pump stations, necessary size of pipes to handle this flow, or potentially treatment plants to accommodate for an additional connection that pulls this flow area to a new pump station set and treatment plant. So the information we calculated here can be used for many different uses and can be put in reports. And this is just one example of how we utilize data spatially here at HRSD.